All right, so what I want to do here first of all is just kind of review how we do this. So when you do P, remember that's all the factors of 54. Now we're just going to do this logically. So you're going to have a plus or minus for everything. I'm just going to do it like this. So you have 1 and 54. I like to just kind of start outside in and kind of work my way like that. 2 goes into 54 27 times. You can use your calculator to help a little bit with that. 3 goes into 54 18 times. So we got 3 and 18. And then the only other thing, 4 doesn't work, 5 doesn't work, but 6 goes in 9 times. Okay, so what I've got, I'll write that a little more clearly, is 1, 2, 3, 6, 9, 18, 27, and 54. And then they're all plus or minus because your zeros can be negative or they can be positive. Okay, now Q, of course, is the leading coefficient. So the number in front of that's 1. So that's just plus or minus 1 like that. Okay. Now what we do is we do the P over Q list. So you're just doing 1 over 1, 2 over 1, 3 over 1, and so forth. So you actually just end up with the same list that you have for P. So that would be 1, 2, 3, 6, 9, 18, 27, and 54. Okay, so I just want you to remember how to do that. All right. Now what we do on this, what's the degree of the polynomial we're working on? 4. What does that tell you about the maximum number of zeros?
4.
That's 4. Okay, we talked about that a lot last time. Now, some of them could be complex. Some of them could be real. So what you want to do on this, if you have a problem like this on your homework, just get your calculator out and see if you can find a 0 to begin with. Okay, so I'm going to go ahead and I'll have you put this in because there's a couple things I want to talk about on this. So I've got x to the 4th plus 5x to the 3rd. And then we got plus 15x squared. Okay, and then plus 45x. And then plus, is that a plus 54 or is that a minus 54? Plus 54, okay. All right, so let's just do that in a standard window. So I'm just going to go zoom number 6. And let's see if that's good enough to find a 0, okay. All right, so it looks like there's probably 2 zeros right there. If you look at that, I'm thinking maybe -2, maybe -3. That's what I'm seeing right there, okay? So what I'm going to do on this then is notice that -2 and -3 are in your list, okay? And that's not always that way, but sometimes it is. So what I want you to go ahead and do is let's pick one of these. Let's start with -2. And we're going to do synthetic division into the polynomial. There's no missing terms, so we have 1, 5, 15, 45, and then we have 54 like that. Okay, so go ahead and start your synthetic division. And what's the remainder going to be?
0.
0, we think, okay, because that's what it looks like on the calculator. Good, okay? So I bring this down, that's 1. Multiply, that's -2. Add the column, that's 3. Multiply -2 times 3 is -6. Add the column, that's 9. -2 times 9 is -18. Add that, that's 27. And then finally, -2 times 27 is -54. So we knew that was going to happen. Okay, so our first 0 officially is -2. Okay? Now, right now, remember, this is a remainder. This is a constant. This is 9x, this is 3x to the 2nd, and that's x to the 3rd. So we have to synthetically divide again. So what you want to do is take this result. So you want to divide that by the other thing that we found on the calculator. So if you just write down the 1, 3, 9, and 27, the other 0 it looked like on the calculator was -3. And it doesn't matter what order you do this division in. So we're going to go ahead and do that synthetic division, and we should get a second 0. But be sure you divide that into the result because you want to get this down to a quadratic equation. So that comes down, that's 1. This would be -3. That adds to 0. This is 0. That's 9. And then you would have -27, and then 0 like that. Okay, so that's what you kind of expected to happen. So now we have this, okay? Now, what I want to see is if you caught on to what I was talking about last time or not. Now, I'm going to zoom out on this thing a little bit. I'm just going to do zoom out. You don't need to do this, but just you can pay attention to it if you want to. Okay, so if I do this and do the zoom out, let me show you what will happen here, because I want to ask you a question on this and see if you understand this or not. Okay, so it looks like it touched the x-axis twice. Okay, what does that tell you about the other two zeros? They're complex, exactly, right. So you can tell by the graphing calculator that since it doesn't touch again, you got two more complex roots, okay? If you don't know that, it wouldn't make any difference. You'd find that out anyway. But what you're going to end up having, of course, that's a remainder. This is a constant term. That is 0x, and then that's x to the second. So what you have left over is x to the second plus 9, like that, okay? And then what you do is you set that equal to 0, and then you solve that equation. And they're going to be complex, because what you would do is move the 9 to the other side, so you would have x squared equals -9. And when you do the square root, you're doing a square root of a negative number, so that's why it's complex. So that would be x equals plus or minus. And how do you write square root of -9?
9i.
3i, right?
Oh.
Yeah, because you do the square root of 9 and get 3, right? Okay. Remember, that's just I times square root of 9, but the square root of 9 is 3, so it'd be plus or minus 3i. Okay, so that means the other two zeros are going to be 3i and -3i. Okay, so it touched the x-axis twice because there's two real zeros. It didn't touch the other two times like that. Okay, all right, is everybody with me there? Okay, now what I'm going to do here is we're going to do the factored form. We have 4 factors since we have 4 zeros. And I'm just going to put it together this way. So we always say x minus whatever the zeros are. And then you can kind of simplify from that point. So you want to know how to use this to write this polynomial in a factored form. So that would be x minus -2, x minus -3, x minus 3i, and then x minus -3i. Now you can change those signs in your head if you want to. I just like to show you how you start that out. So actually the final answer would end up just being x plus 2, x plus 3, x minus 3i, and then x plus 3i like that. Okay, so that would be your solution to your problem in your factored form. Okay, that's how that works out. Okay, so in this section, the only thing that's going to show up that's a little different is you'll have complex numbers. That's it. Okay. Any question about that? Anybody? Okay. All right, that'll wrap that up, and then I'm going to go ahead and I'm going to give you the first thing we're going to work on today is 5-4. Go ahead and shut that off.